Hi guys, here's your video on section 4.4, trig functions of any angle. After you're done watching the video, you should be able to evaluate trig functions of any angle. So what we're looking at today is trig functions of actual points. So you have this ordered pair x and y, so here's your drawing, here's your ordered pair x and y. And once I have that point, I can set up a triangle where this is my x distance, this is my y distance, and then r just represents your hypotenuse of that right triangle. So in terms of trig functions, sine is your y over r, because here's your angle. Sine is y over r, since sine is opposite over hypotenuse. Opposite over hypotenuse. Cosine is x over r, since cosine is adjacent over hypotenuse. And tangent is y over x, since tangent is opposite over adjacent. And of course, if I know sine, cosine, and tangent, I can solve for cosecant, secant, and cotangent. By the way, to find this r, that's just using the Pythagorean theorem of a squared plus b squared equals c squared. So you can look at r equaling x squared plus y squared, and then the square root. That's just going off of the Pythagorean theorem. There you go. Okay, so let's do an example. So find the exact values of the 6 trig functions of theta if theta is in standard position and p is on the terminal side. So I'm going to go ahead and sketch out where this is. So 8, negative 15, my x is positive, my y is negative. That puts my triangle in the 4th quadrant. So this distance is 8, this distance is negative 15, and then I'm going to go ahead and find my hypotenuse, which is the square root of 8 squared plus negative 15 squared. Let's see what that gives us. So 8 squared plus negative 15 squared is the square root of 289, which is a perfect square, so r is 17. So that makes this hypotenuse 17. Okay, so cosine, let's see, cosine of theta. Cosine of theta is x over r. My x is 8, r is 17, so that's 8/17. Sine of theta is y over r, so that's negative 15 over 17. Cosine, we already found cosine. Tangent of theta is y over x, so negative 15 over 8. You could also use your drawing because you have opposite, adjacent, and hypotenuse. So cosine is adjacent over hypotenuse, sine is opposite over hypotenuse, and tangent is opposite over adjacent. And once I have those 3, I can find the other 3. So cosine matches up with secant, so that's 17 over 8. Sine matches up with cosecant, so that's negative 17 over 15. And then tangent matches up with cotangent, which is negative 8/15. Alright, letter B. Negative 2, negative 3 is in the 3rd quadrant. So this side's negative 2. That side's negative 3. I'm going to go ahead and find my r, which is the square root of x squared plus y squared. Just using the good old Pythagorean theorem. So that gives us a square root of 13, which is not a perfect square, so we're going to go ahead and leave this side as the square root of 13. Alright, so cosine is adjacent over hypotenuse, or x over r, so negative 2 over root 13. Can't have radicals in the denominator. So that's 2 root 13 over 13. Sine is opposite over hypotenuse, so that's negative 3 over root 13. negative 3 root 13 over 13. Tangent is opposite over adjacent, or y over x, which is negative 3 over negative 2, or positive 3/2. And then for secant, secant matches up with cosine. I'm actually going to flip over this original value we got for cosine because, you know, this one looks a little more complicated to flip over. So when I flip over negative 2 over root 13, that gives me negative root 13 over 2. For cosecant, again, I'm going to flip over this original value we had for sine. That'll prevent me from having to change the radical from the denominator. So that's negative root 13 over 3. And since tangent is 3 over 2, cotangent is 2 over 3. All right, letter C. Let's go ahead and sketch this one out. 0, negative 4. Well, where is 0, negative 4? Oh, that's right here. So you don't really have a triangle to work with. So you can't really work with SOHCAHTOA, where sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. In this case, you actually just have to work with your points x, y, and r. But let's go ahead and find r, just like we did with the other ones. It's the square root of x squared plus y squared, which gives you 4. So r is 4. Cosine is x over r. So that's 0 over 4. 0 divided by 4 is 0. Sine is y over r, so negative 4 over 4, which is negative 1. And tangent is y over x, so negative 4 over 0, which is undefined, because you can't divide by 0. Cosine matches up with secant. So when I take the reciprocal of 0, that is going to be undefined. So when the original trig function is 0, its reciprocal is undefined, and vice versa. Sine matches up with cosecant. Cosecant of theta is negative 1, so that means, sine of theta is negative 1, so cosecant is also negative 1. Cotangent matches up with tangent, so since cotangent is undefined, that means cotangent is 0. I think I keep saying this backwards. So tangent is undefined, so that means cotangent is 0. Sorry if what I'm saying is not matching out with what I'm writing. There's a lot of sines, cosines, and tangents, and all these trig functions just flying around everywhere. So, yeah. Okay, so that is this example. The next thing we're looking at are trig ratios and the quadrants. So let's look at the quadrants first. And what I'm looking at with the quadrants is I am looking at the actual signs of the points in the quadrant. So for example, my first quadrant, my x's are positive, y is positive. Second quadrant, x is negative, y is positive. Third quadrant, they're both negative. And fourth quadrant, x is positive, y is negative. Now, I'm trying to figure out what quadrant is going to have tangent of theta being less than 0 and cosine of theta being greater than 0. So if tangent of theta is less than 0, that means this value is negative, right? Because less than 0 means negative. Cosine of theta is greater than 0, so that means cosine needs to be positive. So what you need to remember to figure this out is that cosine is your x, sine is your y, tangent is y over x. Okay, so what I'm looking for is I'm looking for a quadrant, so I'm going to start with this first. I'm going to start with a positive x coordinate. So positive x coordinates are these two quadrants. So I've narrowed it down to two quadrants. out of these two quadrants, I need to find which quadrant has a negative when I divide my y-coordinate by my x-coordinate. Well, if I look at my first quadrant, I'm taking a positive divided by a positive, that equals a positive. So it's not going to be my first quadrant. For my fourth quadrant, when I take a negative divided by a positive, the result is negative. So that means this right here is going to be quadrant 4. All right. Cosecant of theta is the reciprocal of sine. So what I'm looking for is I'm looking for my sine of theta. I'm going to write this down. I want sine of theta to be positive. Sine is my y-coordinate. So I'm looking for the quadrants that have a positive y-coordinate. Cotangent matches up with tangent. And I want my cotangent to be negative, so that means tangent also has to be negative. So that means when I take my y-coordinate over my x, that needs to be negative. So a positive y-coordinate are these two quadrants, quadrant 1 and quadrant 2. And then for my tangent, or my cotangent, that needs to be negative when I divide my x-coordinate by my y-coordinate. So if I look at quadrant 1, a positive divided by a positive is positive. But for quadrant 2, positive divided by a negative is negative, and that's what I'm looking for. So that means this is in quadrant 2. So you're looking for which quadrant meets the qualifications for both of these trig functions. So you just need to remember that cosine's your x, sine is your y, and tangent comes from dividing your y by your x. And then choose the appropriate signs, and that'll tell you which quadrant you're in. Now that I know how the signs of the quadrants relate to the trig functions, I can find exact values of 6 trig functions using the given trig function and the sign of another trig function. So I am given that cosine of theta is 1/2. Well, the value of 1/2 you can clearly see is positive. And I'm also given the fact that sine of theta is less than 0, so that means sine is negative. So what I'm going to do is I'm going to go ahead and draw a triangle in the quadrant that has a positive cosine with a negative sine. So that means I'm looking for a positive x with a negative y. So the quadrant that has positive x's are quadrants 1 and 4, but the one that has a negative y is quadrant 4. And cosine is my adjacent over the hypotenuse, so that makes my adjacent side 1 and hypotenuse is 2. And I can use the Pythagorean theorem to solve for that third side. So I have 2 squared equals a squared plus b squared. So that's 2 squared minus 1 squared is 3. So 3 equals b squared. So that means b is the square root of 3. So this side right here is the square root of 3. Now before you start solving for the other trig functions, we do need to pay attention to the quadrant that we're in. And in that fourth quadrant, my x is positive, but my y is negative, which means that square root of 3 should be negative, not positive. So for my 6 trig functions, my 6 trig functions are cosine, sine, and tangent, followed by secant, cosecant, and cotangent. Now the original problem gave me cosine, so I already know that that's 1/2, which means if I know cosine, I know secant because it's the reciprocal of that. So really what we're finding is 4 other trig functions, not 6. But sine is my opposite over hypotenuse, so my opposite side is negative root 3. Hypotenuse is 2. Cosecant, when I flip that over, is negative 2 over root 3, which we have to change to negative 2 root 3 over 3. And then tangent is opposite over adjacent, so that is negative root 3 over 1, or just negative root 3, which makes cotangent negative 1 over root 3, wrong color, which is negative root 3 over 3. So those are the other trig functions when I give you the initial trig function and the sign of another trig function. Alright, so the next one I'm looking at is tangent of theta is 4/3 and cosine is negative. So I can clearly see that 4/3 is positive. And tangent comes from dividing by y over x. So I'm looking at when I divide the coordinates, which one is going to give me a positive value, as well as cosine of theta being negative. Cosine's my x coordinate, so I'm looking for when my x is negative. So your x is negative in quadrants 3 and 4. But the quadrant that results in a positive sign when I divide my x by or my y by my x is quadrant 3. Because in quadrant 3 I have negative, negative, and when I divide a negative by a negative it gives me a positive value. So sine is opposite over adjacent, so my opposite side is 4, adjacent side is 3. But keep in mind you are in the third quadrant, so that means your x is negative and your y is also negative. So you physically need to make those two sides negative. I can use the Pythagorean theorem to solve for that third side. So I have c squared equals a squared plus b squared, and you get c equals 5. So this hypotenuse is 5. Now for my trig functions, I'm trying to find cosine, sine, and tangent. Once I have those three, I can find secant, cosecant, and cotangent. And I did give you tangent to start, so I already know tangent is 4/3, which I know which means that cotangent is 3/4. And then I can use my triangle to find the other 4. So cosine is adjacent over hypotenuse, so that's negative 3/5. Sine is opposite over hypotenuse, so that's negative 4/5. And since I now know those two, I can flip them over to find secant and cosecant. So that's negative 5/3 and negative 5/4. Okay, the last thing we're looking at is just refreshing on how to use the calculator. So again, double check your mode. So if you look at A and B, both of those are in degrees. C and D, both of those are in radians because you don't actually have that degree symbol. So I'm going to change my mode to degrees since my calculator was already in radians. So hit mode. Make sure the word degree is highlighted. And then I'm literally going to type in sine of 97 and then hit enter. This says to go to 4 decimal places. So that is 0.9925. And then for secant, you don't actually have a secant button on the calculator, so I'm going to do 1 over cosine of 202. Since cosine and secant are reciprocals of each other. So 1 divided by cosine of 202 is negative 1.0785. And then for tangent, that is in radians, so I'm going to change my mode to radians. And then I'm going to type in tangent of negative pi divided by 10. That gives me negative 0.3249. And then cotangent, I don't actually have a cotangent button, but what I can do is I can do 1 over tangent of negative 0.83. So 1 divided by tangent of negative 0.83 is negative 0.9145. So just a little refresh on using the calculator. Alright, so that concludes your notes for section 4.4.